Hi guys. Today we're going to start Unit 7 on random variables. It's another probability unit. So we call random variables, we use RV to mean random variable in this unit. And what is a random variable? So we will define that first. It's a variable whose value is a numerical outcome of a random phenomenon. So for example, if you flip a coin 4 times, or 4 coins, whatever, there would actually be 16 outcomes because it's 2 to the 4th, because there's 2 outcomes on each coin. So you'd multiply 2 times 2 times 2 times 2, which means there would be 16 outcomes of the 4 flips. So we're going to define, we call it random variable x, RVX, as the number of heads in 4 tosses. Okay, so there's 16 different outcomes, and we have to figure out what's the probability of each one. So we're going to make a probability table. So there's either going to be 0 heads on the 4 coins, there'll be 1, there'll be 2, there'll be 3, or there'll be 4. Those are all the outcomes. And the probability of each one of those we're going to figure out. So if you think of all the different ways you can flip 4 coins, it could go heads, tails, tails, tails. It could go tails, heads, tails, tails. It could go tails, tails, heads, tails, or tails, 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 heads. That's 4 of them. There's many more. So HHTT is another outcome. TTHH, HTHT, THTH. This is basically 2 of each. So the first column was just 1 heads and 3 tails, but there's 4 different orders of that. This column is 2 heads and 2 tails, but there's a lot of different orders of it. And HTTH. And then there could be 3, which would be HHHT or THHH, or it could be HTHH. Or there could just be, or it could be HHTH. And then, of course, it could just be HHHH. So when there was only 1 heads, that happened. There could be none. There could be tails, 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 which would be 0. So 0 is only going to happen 1 out of 16 times. 1 heads happens 4 different combinations, so 4 out of 16. 2 heads happens the most. That happens 6 out of 16 times, which makes sense because the probability is 1/2. So that's going to happen the most. And then 3 is going to happen 4 out of 16 times. Those are right here. And then 1 time you could get all 4. And of course, all of those should add up to 16 out of 16. All right, so that's the table that you make to figure this out. Oh, usually then you figure something out. But all right, move on. All right, so the next thing we're going to talk about are called discrete versus continuous random variables. Okay, a discrete random variable has a countable number of possible values. A continuous random variable takes all values of an interval of numbers. Which has an infinite number of possible values. So an example of a continuous would be something like if we were measuring everyone's heights. Your height could come out to any number between whatever regular heights are, but it could be a decimal. So you might say, oh, all these people are 5'6", but maybe someone's 5'6.5", someone's 5'6.1/16. So there's basically an infinite number of possible values. So an example of continuous would be like people's heights, or anything that you would really measure. But a discrete random variable is a countable number of values, like something like rolling a die. There's only 6 outcomes and there's nothing in between. So that's discrete. Continuous means any number. Okay, so what we're going to do with this, of course, is probability. Probability distribution of discrete random variable. And that's basically what we did up there. So you're going to display it as a table, or it could be as a histogram too. So you would have the table like we made up there. You'd have a value of random variable x. And then you would have the probability of x. Which we would just call p of x. Whoops. Oh no, undo. Oh no, I don't know what it's doing. Sorry. Let me move this. This is an example we're going to do in a minute. So whatever these values are, x1, x2, x3, x4, and they keep going, whatever they go to. And then the probabilities would be P1, P2. And the reason we need these in this form is because there's a formula that we use that's given on the AP formula sheet. And it's called the expected value. It's also a mean, basically, so we call it mu of x also. So E of x means expected value. And mu of x it's the mean. So an expected value is a mean. It's called a weighted mean. And you get it by doing the summation of xi times pi. So you would multiply each one of those x's by the probability and then add it all up. We're going to do an example so you'll see what I mean. So the expected value for the one we did with the coin toss in 4 coin tosses. It's the sum of xi pi. So that would be 0 times 1/16 plus 1 times 4/16 plus 2 times 6/16 plus 3 times 4/16 plus 4 times 1/16. This is also called a weighted mean. And and you would just add all these up. This adds up to, that's 0, 1/4, 3/4, 3/4 again, and 1/4, which actually comes out to 2. So that's what we call an expected value, and what it means is that's how many you would expect to get. When you toss the 4 coins, you'd expect to get an average of 2. All right, so I have to do like 1 or 2 more examples with you. So these are from the book. So for this first question, it wants the average or the mean, which is the expected value, and they're giving you the grade and the probability. So all you have to do is that formula that we just learned. So you're going to do expected value of the grade, which is mu of it, which means you do grade times probability and add them all up. So it'd be 0 times 0.10 plus 1 times 0.15 plus 2 times 0.30 plus 4 times 0.15, and that all adds up to 2.25. So that's called the expected value or the weighted mean. Okay, I'm going to do one more example. So this one's about the lottery and winning. And this time the random value X is going to be the payoff. And that's without the cost. So it's how much you actually win. So since it's 3-digit number, there's 1,000 combinations of a 3-digit number. But there's only actually 6 ways you can win, because whatever the 3-digit number is, it could be in different orders. So 6 outcomes would win. For example, let's say the winning number was 348. Well, you would win if you got 348, 438, or 834. So there's actually 6 different outcomes. So X is 0. You would either win $0 or 8333. And P of X, you'd win 0 a lot of the time, 994 out of 1,000 times. And you'd win 8333 6 out of 1,000 times. So to do the expected value, it's 0 times 0.994 plus 83.33 times 0.006. So you're pretty much not going to win. The expected value, the average would be 50 cents. That's over many, many times. All right, your homework's in the textbook. Page 396, 7.3, B, C, D, and E, and page 405, 7.16.